Okay, next concept, graphing with calculus. And I'm not going to lie to you, this is a huge pain in the ass. It has a lot of moving parts, there's a lot to put together, and it's not trivial. Now you may be thinking, I'm going to use my graphing calculator. The picture, the graph of the function at the end of this insanity, is going to be worth the least points of the whole thing. There's a lot of work that you have to do before you get to drawing the picture. So I need to start off by giving you a few definitions of some terms that you're going to use. Okay, so I've drawn you a couple pictures. Now, why did I draw these pictures? In order to do the graphing right, you basically just have to figure out where the function goes up and down, where it hits a high point, where it hits a low point. Now, there's special subtleties here. For example, if you look at this first one, this is a parabola. You go up, you come down, you hit your high point. Now, this high point is the high point. The graph does not exceed that. So this thing would be called an absolute maximum. And maximus. Nice. Maximum. No editing, man. You see my mistakes live, and I'm not fixing them. I don't give a damn. Just like if I write the crap on the board in class. The maximus. Actually, that sounds a lot cooler. This is called the absolute maximum, or max for short. All right? Now, obviously, if the parabola was the regular smiley face, you'd have an absolute minimum. That would be the bottom, right? You'd go down and then come back up. Now, this one, your typical roller coaster, you go up, down, up. You hit a high point, you hit a low point. The thing is, if you look at this one and you compare it to the rest of the picture, this guy is not the high point. This goes up forever. So this is not the absolute biggest that it gets. Like, let's say that point there was 5. This is 6, 7, 8, 9, forever. This is not even close to being the maximum. But in his area, in his neighborhood, he is the maximum. So he is the maximum relative to the rest of the picture. So this top one would be called a relative max. In his area, king of the hill. As soon as you look at the rest of the graph, though, he's not the maximum. He's only the maximum in his area. He's maximum relative to the rest of the picture. And this guy, same thing. The graph gets a lot lower. You know, this might be negative 10, right? Y value, negative 10. But over here, y is negative 15, y is negative 20, y is negative 1,000. This is not the low point of the graph. It's only the low point in its area. But you would need these to make an accurate picture. So this is called a relative minimum. And I'm just going to write min this time. Or I could write minimus. All right, so these are the concepts that you need to know how to do. You need to be able to figure out the high point of the graph and the low point of the graph. Once you know those, you can start connecting the dots by going up, down, up. That's going to be the idea of graphing with calculus. And I'm going to show you how you actually do all this and figure it out. Because you're not going to be given any pictures. You have to make the pictures. All right, so like every other concept in Calc 1, if I were to ask you to take a guess at what concept we've covered that's going to help us make pictures, there's only one concept we've covered this whole damn semester that is of any value, and that is the derivative. And if you remember that the derivative is the slope of the tangent line. Now, I'm going to show you real quick. You know, suppose I pick some random dot there, and I make the tangent line. I should probably try to do it in red. I'm going to make a tangent line. I mean, it's not going to be perfect. There's my tangent line. Now, the graph is going up, right? I hope you see that this is like a roller coaster. You're going up, 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 up. You hit your high point, then you go down. The tangent line has a slope that is positive here. And if you were to make any other tangent line along where the graph is going up, the slopes will be positive. This is important. If the derivative, which gives you the slope, if the derivative is positive, that means that the graph is heading up. Likewise, if I come to the other side and I put a point there, and I look at the tangent line here, I mean, I'm drawing these terrible. The slope of this line is negative. So when the graph is going down, the derivative will be negative. Derivative positive, graph going up. Derivative negative, graph going down. But what about here? If I try to draw my tangent line there, I'm going to try to be more careful here. This line is horizontal, left and right. The slope of a line that goes left and right is 0. This is very, very important. That means if my derivative is 0, I either hit a high point or a low point. This is how you're going to use, that's the first part of putting together how you're going to make a graph. You figure out where the graph goes up, where it goes down, where it hits a high point, where it hits a low point. This one doesn't hit a low point, right? It's a parabola. But your graph is usually going to have a high point and a low point. So you figure them out. You figure out where it's going up and down. And then you can kind of get an idea of what the picture is going to look like. That's not enough, but it's a start. So as always, I have to give you definitions before I can start actually doing anything. So there's going to be this thing called critical numbers. These are numbers where you take the first derivative, you set it equal to 0 and solve, you get those numbers. They're numbers that when you plug them into the first derivative, you get 0. Remember, the first derivative tells you slope of tangent line. So this is where, these are x values, where the tangent line has a slope of 0. In other words, this is where the x values could hit a high point, max, or a low point, min, right? Maximum, minimum. So this is what you're going to do. All right, now, how on earth does that help you figure out where the graph is going up and down? Well, I have to give you another definition. So the next definition that I have to give you, now you always read a graph from left to right. When you are talking about x values being plugged in, same thing. X values are getting bigger. You plug in x as 1, then you plug in x as 2, then you plug in x as 3. As you plug in bigger x values, the y values get bigger, then the function is said to be increasing. If the y values are growing, so you plug in x as 1, and then you plug in x as 2, and the y value got bigger, that meant that the graph is going up. If, however, you plug in x's, and the y values start getting smaller, you plug in x as 1, you get y as 10. Then you plug in x as 2, and you get y as 3. And then you get y as negative 1. Then you get y as negative 7. The y values are getting smaller, then the graph is going down, right? That's how you plot points. You put in an x, you get a y. If the y values are getting larger, the graph's going up. If the y values are getting smaller, the graph's going down. And we call that the big duh. Now, this is going to be the way that we determine where the graph goes up and down. I'm going to take my first derivative, and I'm going to figure out where it's equal to 0. Then I'm going to figure out when my first derivative is positive, greater than 0, right? If you are bigger than 0, 1, 2, 3, you're positive. I told you, derivative slope of tangent line. If the tangent lines are positive, then they're going up. Then the graph is going up, f of x, right? That's a function. If you take the derivative, however, and you figure out where it's negative, then you just figured out where your graph is going down or decreasing, okay? So if the first derivative is positive, graph is going up, increasing. First derivative negative, graph is going down, decreasing, okay? Now look, definitions are all well and good, but you need to see an example of how this is all put together. Once you know where the graph is going up and down, then you'll know if you had a maximum or a minimum. So I'm going to work an example, and you'll understand how this all comes together. And this is only the first half. All right, so the example I'm going to work. I'm given this function, which x third minus 3x squared minus 9x plus 2. Cubic function. This is going to be like a roller coaster. It's going to go up, or down, up, down. You don't know. No idea until you try to make a picture. I want to find the intervals on which the function is increasing and decreasing. What the hell is an interval? Now, I can't go back and reteach you pre-calculus, but I will show part of it to you as I'm doing the problem. All right? When you tell me where a function is going up and down, it happens over an interval. So I think I will briefly pause here. I guess just to make sure you're all on the same page as me. Now, look, way out here would be negative infinity, right? Here would be infinity. I want to figure out where this graph is going up. Well, you know, you're starting somewhere here, right? The graph is going up, 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 hits this point. So this graph would be increasing from negative infinity up until it gets to 2. Now, notice, when it hits 2, it hits a high point. So it's not going up anymore, right? When you reach the top of the roller, you know, when you're on a roller coaster and you reach the top of the hill, you start to come down. You're not still going up when you reach the top of the hill. Now, when you start to come down, right, you're falling. So this graph would be decreasing from the moment that you pass 2, and then it goes down forever, right? Now it might come back up. So if there was a second interval, you know, you would do this kind of thing, if you remember from pre-calc, all right? My answers are always going to be like this. My answers are going to be written as intervals because this graph is going up for a series of x's. This graph is not just going up at one point. This graph is going up for an infinite number of points. Any number between negative infinity and 2, if I plug it in, right, any x value that is between negative infinity and 2 will give me a bigger y value. So when I plug in 0 and then 1 and then 1.5, my y values are getting larger. That's what it means for the graph to go up. So that's why you have no choice but to write these answers as intervals. Okay, so recalling the past, done. So I don't think that was a bad idea to go back and refresh your memory about what it meant to have an interval. Now, how on earth do you do this? I'm going to write steps after I do the example, but if I want to know where the graph is going up and down, I need to know where the derivative is positive and negative. So first thing I'm going to do is take the damn derivative. Everything in this class is based off the derivative, so you have to take the derivative. So 3x squared, right? Multiply, subtract, minus 6x minus 9. Whoopee! Now what the hell am I supposed to do with that? Well, you got to find your critical numbers. I have to set this equal to 0. And I'm going to do it with you. No pausing. Set it equal to 0. Now, you should know that you need to factor this. They will always factor. You attempt to use a quadratic formula on this, I'm not going to grade anything else you wrote. So when I give you a problem like this, you're going to factor. I'm going to factor out the 3. Why? Because all these numbers are divisible by 3. And I don't really need it there, right? 3 is not equal to 0. I got to redraw my 2. Came out funky. So x squared minus 2x minus 3. Cross this out, right? The product of two things is 0. So one of them must be 0. This isn't. So I can cross it out. Two numbers whose product is 3. I mean, duh. It can only be 3 and 1. I like to put the negative first, right? That sign I always put here. Negative 3 plus 1 is negative 2. 3 times 1 is 3. Signs are perfect. Now, if the product of two things is 0, one of them must be 0. Now you're in a calculus class. I will allow you to skip this step. You can just jump right to here. I want to point something out that I see all the time in every class I teach. It drives me crazy. People don't do any of this. And somehow they get that. This is complete bullshit and nonsense, and I'm not going to tolerate it. This first derivative, then you take the first derivative and you set it equal to 0. If your equal 0 is not there, then it's not an equation, and then you don't get solutions, okay? If the product of two things is 0, one of them must be 0. Pow. That's how you get these two answers, okay? These are your critical numbers. I'm going to tell you what to do with them in a second, all right? So I want to emphasize, constant doesn't need to be here because you multiplied 3 by this other thing and you got 0. that means that the other thing was 0. This number is not 0, so I want you to cross it out. It's just going to mess you up if it's there, so just get rid of it, okay? It doesn't need to be there. So these are my critical numbers. Now, I haven't answered anything. I've done nothing. I just took the derivative, set it equal to 0, and solved. And I got these two numbers. They're sitting there. I didn't figure out whether the graph is going up and down, and I didn't figure out the max and min. It seems like I didn't do a damn thing, but now I'm ready to do all of this, and I'm going to need more space, so I'm going to have to erase all of that, okay? I'm going to start off with my critical numbers and show you what to do with them. All right, I'm ready to do the next step in the problem. I rewrote my critical numbers at the top. I got 3 and negative 1. I rewrote my derivative. This is important. I need to figure out where the derivative is positive and negative. Now, I know that when x is negative 1, if you were to put negative 1 in here, negative 1 plus 1 is 0. 0 times anything is 0. Negative 1 plugged into the derivative gives me 0. That's how I got this damn number. Same thing with 3. Put 3 there. 3 minus 3 is 0. That makes that whole thing 0. So again, I'm not going to plug these numbers into the derivative anymore, because I already know when I plug them in, I get 0. That's how I solved for these numbers. What I am going to do, though, is plug in numbers that are not these. Now notice, when I put those two numbers on a number line, I get 3 regions, left, middle, right. I'm going to pick a number in each region as a test point. And I'm going to write TP for test point. What I am also going to do is put my endpoints there. And I'm going to highlight them in red. I'm going to have to write my intervals down. And I need to use the endpoints when I write my intervals. So you'll see. All I'm going to do right now is I'm going to start checking signs. I'm going to take these little test points. I needed to pick a number to the left of negative 1 in this area. Could I pick negative 5? Sure. Could I pick negative 100? Sure. You can pick any damn number you want. I needed to pick a number between 3 and negative 1. Could you pick a half? Yeah. I don't know what the hell you pick a half for. Could you pick 1? Sure. Could you pick 2? Sure. I decided to pick the easiest number possible, which is 0. Now, I need to pick a number bigger than 3. You want to pick 100? Knock yourself out. It doesn't matter. Whatever number you pick larger than 3 is going to give you the same sign when you plug it into the derivative. It doesn't matter. So I'm going to do the stuff over here. All I care about is whether it's positive or negative. I care about the signs. So first I'm going to check x equal negative 2. I'm going to go to my derivative, and I'm going to replace the x's with negative 2. And I'm going to determine my sign. I get negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1. Negative times a negative is positive. Messed up my 3. So I get 15. Do I give a shit about 15? No, I don't give a shit about 15. I care that it's positive. I don't care about the number. I'm not looking at the value of the number. I am looking at the signs. If the derivative is positive, then the graph's going up. So I'm going to put a huge big-ass plus here to indicate my graph's going up. Now, I think that my graph will come down. I don't know for sure. There's plenty of graphs where you go up, and then you go up, and then you go down. Don't assume that you're going to go up, down, up. This one may work out that way, and I'm pretty sure it does. But they don't all work out that way. The graph could go down, down, up, down. It could go up, down, down. You don't know. You have to test them all. Now I'm going to test 0. Same thing. I'm going to plug it into the derivative wherever there was an x. Where x is, I put 0. See, 0 is nice. This is why I use 0. Now I get 3 times negative 3 times 1. Remember, is it negative 9? Yes, I understand it's negative 9, but I don't give a damn about negative 9. I just care that it's minus. So I'm going to put a huge-ass minus there. Okay? If you want, you can put little squigglies to represent the different areas. Graph going up, graph going down. Now I have to do the last one. The graph might keep going down, or it might come back up. I don't know. So I'm going to test one last number. Like I said, if you want to pick x is 5, x is 100, who gives a dang? Pick whatever you want. So 3. Again, you don't even need this 3 there. This 3 doesn't affect the problem, right? I'm going to put 4 wherever x is. This gives me 3 times 1 times 5, which is 15 again. Do I care that it's 15? No, I don't care that it's 15. All I care about is the graph is positive there. So, increasing, decreasing, increasing. This was a roller coaster. The derivative, any number, no look, you don't believe me? Pick x is 100. 100 minus 3, positive. 100 plus 1, positive. Positive times a positive, positive. Any number you pick larger than 3, 5, 7, 11, 20, whatever number you pick that's larger than 3, you will get a positive number out here. I just screwed up my thing. So, derivative is positive, derivative is negative, derivative is positive. If you pick any number here, like if I had plugged in 2 for x, 2 minus 3 is negative. 2 plus 1 is positive. I'd have a negative times a positive, which is negative. Any number you pick in this region will give you a negative when you plug it into the derivative. So now, I can write where the graph is going up, and I can write where the graph is going down. And I'm going to. The graph is going up. Now, this is why I did this. This is the part that people screw up and have trouble with. This is why I did this in red. The graph is going up till you reach here. Not here. Not your test point. The graph goes up until you hit -1. -1 is your critical number. So this graph is going to go up from negative infinity until you reach -1. Now, that's not the only place it goes up. It's going to go up again when it hits 3. It stops going up when it hits -1 and it starts to go down. It's going to increase when you hit 3, just as soon as you get past 3, and then forever. So now, where is it going down? Well, it's going down wherever it's not going up. It's decreasing between -1 and 3. That's where I have the negative. Okay? So graph goes up, down, up. Now, notice, I'm still not done. I didn't even tell what the max and min are. But if I know this graph went up, right? It went up. I mean, I'm going to mess up my whiteboard if I do this. This works out nice on chalk. If I go up and then come down, this had to be a high point. And then if I go down and then go back up, then this would be a min. Now, these are not the points. These are the x's where you reach a max and where you reach a min. I have to compute them. So I'm going to do that in the next step. Like I said, these problems, this is only the first half of the question. These problems are extremely long and time-consuming to try to make this picture. That's why there's generally only one of these on the final, and it's worth 10 points all by itself because it takes a very long time to do. And making the picture isn't even the most important part. All of this work is. All right, so to create a little more space, I erased the problem and all of the work from before. So again, like I said, this graph goes up, down, up. Kind of, sort of. Now, there's some weirdness that goes on in here that we haven't discussed yet. That's the second half of the lesson that I'm not doing in this lesson. And that's the shape. So up, you hit your high point. You come down, you hit your low point. I mean, you can see that just by knowing where the graph goes up and down and hits the high and the low, that you can, I mean, this picture's going to look a lot like that. I mean, it's a roller coaster. You go up, down, up. I mean, that's it. But it's not accurate. And the shape of the curve is missing, and that's the part that you have to do with calculus also. But to this part, here's where it goes up, here's where it goes down. So I figured out that my high point happens when x is -1. So you can't assume that, oh, the max 3, 3 is a bigger number. This has nothing to do with the maximum and minimum. Okay, in this particular case, the maximum y value will occur when x is -1. The smallest y value will occur when x is 3. Now remember, these are relative maxes and mins. These are not absolute high point. Okay, this is not absolute maximum, absolute minimum. Now, I need to know what they are. So I'm going to plug where? Well, if you were to try to plug this into your derivative, you're going to get 0. That's where this number came from. You took the first derivative, you set it equal to 0, and you got this number. So you don't want to plug this number back into the first derivative. It doesn't make any sense. I'm looking for the y value that goes with this dude. So I got to plug him back into the original function. That's why I wrote it here. So, you got to just do the math here. You should be thinking, this is such a pain in the ass. This is so much work. It is. Negative 1 cubed is negative 1. That's 1 times negative 3. Negative and negative is positive. So you get 11, right? 9 plus 2 is 11. Take away 4, which is 7. So that's what the max is. So I think I'll write it over here. Max, negative 1, 7. If you were going to attempt to make a picture, at some point you have to have some points to plot and play connect the dots. You need something to draw. So, you have to have dots. So you have to find them. Now I'm going to just do the next one real quick. Now the most hysterical part of this is I screwed this up like 4 times while I was trying to write it. And I had to keep erasing it. Not that I did anything wrong. I had wrote a squared here, then I wrote a 2 there, doing all sorts of ridiculous. So I need to plug 3 into my original function here to find the y value. So I do 3 to the third, it's 27. 3 squared, which is 9, times 3, which is negative 27, because it's minus 3. Minus 9 times 3 is another negative 27, and then the plus 2 is just hanging out there. Now, these cross out. 27 minus 27, I'm pretty sure is 0. If you owe me $27 and you pay me 2, you owe me 25. Wow, that's a big number. Now, I want to point out that it's tough to draw points like this that are this far down. So I'm going to show you how I cheat when I do these. So on the side, you see I drew a little graph now. This would be the point negative 1, 7. This would be the point 3, negative 25. Notice, I'm not going to sit here and make 25 tick marks. I'm also not going to count by 2s, and make like 13 of them and go all the way down to like 12 and a half. It is ridiculous. You don't make the tick marks here. You can just cheat this. I know that the graph is going to go up, down, up. The problem is the down part. You see that if you try to draw this down like this, it doesn't work. This does not go down like that. There's stuff that happens in the middle here as it's on the way down that affects the shape of the curve. That's the second lesson of this. But right now, I do know that it's going to go up and hit there, come down, and then go back up. So that's roughly what the picture looks like. So this was your max, and this was your min. Okay? So this is what you do. On the previous board work, I took the derivative, I set it equal to 0. I found those numbers. I put those numbers on a number line. I picked a bunch of test numbers in each region, in each piece, or each chunk. I plugged those numbers into the derivative to see if it was plus or minus. Then I figured out where the graph's going up and down. That tells me where the max and min are. I plugged in those numbers, and then I figured out this is the maximum, 7. This is the minimum. Negative 1 is not the maximum. Negative 1 is the x value where you get the maximum when you plug it in. It's important you understand this, okay? So this is the this point is the maximum, but the y value is what the max is. It's the largest y value and the smallest y value. Okay, I'm going to write a little summary of what I did, and then there'll be a lot of these for you to practice. And unfortunately, these steps are so long and complex, I'm going to end up having to continue it after I go over this briefly. This is how you figure out where the function is going up and down and what the max and min is. I mean, you start off real easy. You take the derivative. You screw this up, you're done. The whole problem is wrong. Don't do anything careless and ridiculous. I mean, I've seen people take the derivative of x third wrong. They write 3x instead of writing 3x squared. And then the whole problem is shot. You just totally effed yourself. So please, be careful. Don't do anything dumbass here. Take the derivative right. Now, take the derivative and set it equal to 0 and solve for x. This is almost always going to involve factoring, okay? not the quadratic formula. You factor, okay? So set the derivative equals 0, solve for x. The numbers you got are critical numbers. Now you're going to do what I did. You're going to take those critical numbers, you're going to put them on a number line, and you're going to pick test points. Now, again, just pretend for fun. Let's say my critical numbers were x1 and x2. You see, there's 3 regions there. I want you to pick a test point in each region. You pick a test point here, here, and here. Those would be your test points. Where do you plug them? You plug them into the derivative. If you plug them into the derivative and you get a positive, the graph is going up. If you plug them in and get a negative, the graph is going down. This graph would be going up, up, down. So you'd go up, 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 down. You'd have a max. There'd be no min there. So this is what you do. Determine max and min. That's a little more complicated. Like I said, you have to decide if the graph is going up and then down or down then up. But I'm going to talk about that separately. This is the last step, which I'm not going to be able to fit here because I want to explain what to do there. So critical numbers go on the number line. Pick test points in each region. You might have 3 critical numbers. It does happen. And then you would have 4 regions. Things get crazy when that happens. Picking a number in each region, plug them into the derivative. If the derivative is positive, up, up, up. If the derivative is negative, down, down, down. And then you write the intervals, okay? I'm going to do this last part separate. All right, so when you do this part, you have to do a little analysis. If the graph is going up and then it starts to go down, you hit a high point, right? I mean, if you're going up, 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 and then all of a sudden you're going down, at some point you hit the top and you came down, so then you have a maximum there. But if the graph was going down, and then you go up all of a sudden, then you hit your low point. That's a minimum, okay? So you have to look at the pictures of the graph that you drew with the signs. So just to illustrate this, I drew a couple. Like this graph. This graph is going down, hits that point, comes back up, hits that point, goes back down. Now look, this is not what the picture looks like. You notice I'm not drawing the curves correctly. I'm missing that part. That's why I can't make the graphs yet. But I can figure out that here I hit my low point, and here I hit my high point. So this would be my min, this would be my max. My graph went down and then up, so I have a min. It went up and then down, so I have a max. Now this one goes up, up, down. Again, this curve is not going to look like I'm drawing it. I don't have my arcs right. I don't have the shape right. That's lesson 2. But I do know that I hit a max here. Now, do I have a min? I don't have a min. I went up, up, down. Where the hell's the minimum? You didn't go down and come back up. So this graph doesn't even have a min. It went up twice and then it went down. So you only had a high point. So you make this analysis for this final step based on what your signs were in the number line graph that you made. You made yourself like a little rough number line sketch. So you kind of have an idea of what the graph is doing in terms of up and down, okay? So this last step is not trivial. And then again, once you do that, plug in and find y. Well, plug in where? I want to make sure we're all clear on this. You plug into the original function. Once you know, hey, this is a min, this is a max, I need to know what the y values are if I'm going to plot those points. I have to play connect the dots at some point and make a graph. So I need the y values. You get y by plugging into the original function. The derivative doesn't give you y values. The derivative gives you slope of tangent lines. So you have to plug the critical numbers, right? These are critical numbers. Whatever numbers you put there on the number line are your critical numbers. You plug your critical numbers back into the original function f of x, and you get the y values, just like I did in my example. So, I only worked the one because, you don't need to see a million of these work. You need to do them yourself. So, as I always say, I'll wish you luck. And the second part of this is going to get a little nastier. And it's very hard to put it all together and make the picture. So you'll see.